So this problem is pretty straightforward. It's really easy. It says this problem 28.31. Okay, for those of you that have the University Physics textbook, the 13th edition, this is the one that is. Okay, if not, you can find it on the 14th edition as well, because I have it too, but the number is just different. It's probably 32. So two long parallel wires are separated by a distance of 0.4 meters. The currents at 1 and 2 have the direction shown. Calculate the magnitude and the force exerted by each wire on a 1.2 length of the other. Is the force attractive or repulsive? Each current is doubled, so the current 1 becomes 10 amps and 2 becomes 4 amps. Now, what is the magnitude of the force that each wire exerts on a 1.2 meter length of the other? So, it's saying to find the force. It's saying to find the magnitude of the force right here. The magnitude of the force. But then I don't see, you know, on the last questions it had the force per unit length, and that was a formula. The formula was force per unit length. Of mu sub 2 pi r, and it was I times I, which was the current. But right here it's just saying the magnitude of the force. So I mean, all you have to do is just pass the L to the other side. So the force equals to mu sub naught current times L, 2 pi r. Pretty simple and straightforward. Okay. So, calculate the magnitude of the force. That's what we're gonna do. So, all we have to do is just plug in. The first current was 5 centimeters. The first current was just 5 amps. So force is equal to mu sub naught 5 amps, and then the other one is 2 amps, and then the length, it was the length is 1.2 meters over 2 pi, and r should always be the distance between one current to a point or to the other wire. So right here it is to the other wire in this case. So 0.4 meters. And then when we plug everything in here, and then we know what mu is already, it's 4 pi times 10 to the negative 7 Tesla meters per amp. When we plug everything on the calculator, we should get 6.0 times 10 to the negative 6 newtons. Okay? And the forces are repulsive, and they should be going opposite directions. That's how you spell repulsive. Okay. So this is part 1. Let's see, that's part 1. Part A, I'm sorry. And then part B is the same thing. Part B. Part B is the same thing, except for redoubling the current. So you got 10 amps instead of 5 amps. and then you get 4 amps instead of 2 amps. So I mean, all you have to do is just cancel this out, because the 2 that you put here to double it divides by the 2, and then it cancels out. So then you will be you will have 5 amps times 2 amps times 1.2 meters, and then you get pi times 0.4 meters. So then you will get 1.2 times 10 to the negative 5 newtons. Okay.